Greetings! Welcome to practice problem 6 from lesson 9.3. We're going to work with quadratics here and use the quadratic formula to solve them. So they drag you through kicking and screaming, filling in the blanks with this early one, and then we'll move on to more complicated ones in the following slides. So the very first thing that we should always do is recognize that we are actually working with a quadratic. In other words, we're working with ax squared plus bx plus c is equal to 0, and then that infers to us that we're going to solve that using the quadratic formula as x is equal to the opposite of b plus or minus the square root of b squared minus 4ac all over 2a. And if you have not yet memorized that, please do memorize that formula. There's a wrap on the assignment link that can kind of help you get that thing into top of the head. Okay, all right, let's get after what they want us to do here. So they give us this one where they ask us to fill in the blanks, kind of hold our hand through it a little bit. So the first thing they want us to do is identify a, b, and c in the given quadratic. 2x squared minus 2x minus 4 is equal to 0. So a is equal to 2, b is equal to negative 2, and c is equal to negative 4. So come in here and place everybody using copious amounts of parentheses, and we get negative 2 in here for a b, negative 2 in here for a b, and we minus times 4 times a, which was 2, times c, which is negative 4, all over 2a, which is going to be 2 times 2. All right, so step from here to here, the next line we got a negative is a positive, so that is a positive 2 now that goes in here. Got negative 2 squared, that's going to give me back a 4. I got negative 2 times 2 times negative 4. Well, that's, if you ignore this negative for a second, that's going to be a negative 16 times 2, which is a negative 32, which is what they're asking us to put here. But the thing to notice is that a negative and a negative is a positive, so it changes that sign into a positive right there. Okay, and then 2 times 2 in the denominator, that's going to give us back a 4. So that 2 comes along for the ride in the view, and then we've got 4 plus 32, that's going to be 36 divided by 4. And so now breaking up the plus or minus, that tells us that's going to be 2 plus the square root of 36 divided by 4, and 2 minus the square root of 36 divided by 4. Notice that now they've labeled them x1 and x2. Be careful in the My Open Math homework. It's important that you input the correct answer for the correct variable. So if they tell you x1 is the positive one and x2 is the negative one, and you switch that order, it's going to mark it wrong on you. So be careful of that. All right. Now normally the square root of 36 would not simplify. And, well, I mean, normally in that many times these problems you do not get a nice perfect square in your square root. But when you do, you need to simplify that. So this is going to be 2 plus 6, which is the square root of 36, and then 2 minus 6, which is, again, the square root of 36. So 2 plus 6 divided by 4 is what x1 is, and 2 minus 6 divided by 4 is what x2 is. So 2 plus 6, that gets me an 8 divided by 4. And then 2 minus 6, that gets me a negative 4 divided by 4, which, yes, indeed, gives me a 2 and a negative 1 for our solutions. All right, so then they want us to go over here and actually put in a graphical solution also. So let's get our calculator out. So getting at our calculator here, we're going to enter into y1, x squared minus 2x minus 4 into y1. And then optionally, if you like the intersection routine better than you do the zero routine, you can put y2 is equal to 0, and that'll let you find the zeros by finding the intersection. Okay, so we're going to go ahead and press a zoom and a 6 for zoom standard, and sure enough, looking like we're getting the exact same solutions that we did when we did it by hand. So let's come over here and make a sketch on our homework sheet. Let's go ahead and fatten up that line just a smidge here. Okay, so there's our glorious x and y axis system. We'll put an x there, we'll put a y there, going negative 10 to 10, negative 10 to 10, giving them our window settings. And the parabola looks not quite unlike, but similar to that, where that right there is at 2, 0, and this one over here is at negative 1, 0. But I'm doing that by eyeball. Let's go verify that numerically on the calculator real quick. So to do that, we would go second, calc, and then we can use the zero finder here. if you'd like, or you can use the intersection. I'll show you both. We'll do one with one and one with the other. With the zero finder, you have to get the frog, the cursor, to the left where it crosses the x-axis. Now you got to get it to the right where it crosses the x-axis, and now you got to get the best guess. And that, voila, comes back out to -1. It tells us the 0 is at -1, 0. Nice. Okay, so what about if we wanted to use the intersection routine, because I'm not so keen with that left bound, right bound stuff? Well, if you go to the y equals menu and you put in y2 is equal to 0, then you can use the intersection. But if you don't give it the equation of the x-axis, you won't have two equations for it to find the intersection of. So second calc number 5. And now we're going to get the first curve, second curve, best guess. So there's the first curve. Notice the second curve now is the x-axis and my best guess, and voila, we come back out x is equal to 2. Okay, so digest that one for a little bit. I'm going to come back and do a bunch more of these problems in another short video, but I think that's enough to get you started, and then we'll get a bunch more.